Okay, so hello future engineers. Good day. So for this discussion video, we will be talking about continuous distribution of charge and we will be computing for electric field. Technically, this topic is the last topic for electromagnetics, but I split this into three discussion video in order for us to have a better understanding of the topic. First, we will be discussing about the total concept of electric field due to continuous charge distribution, and also we will be having the physics approach kung paano natin sumahon ang mga problems, and the last part we will be solving some mga calculation based on the electromagnetics nga concept. So we will be introducing some physics nga concept here in order for you pareho sa previous natin nga discussion, you will have a medyo hapos kag medyo dasig lang approach in solving the problem. So okay, so let us proceed with our discussion on the electric field due to continuous distribution of charge. So, in our previous discussion about electric field, we were able to establish some kung anong property or kung paano natin ginasolve ang electric field due sa bisan ang damo-damo pa na siya nga type of charges na present sa isa ka specific na field. And we use the concept of superimposition or ginaad naton ang mga electric field sa mga individual nga charges. So same also applies with electric field kung damo-damo na sila. So what does it mean when we say niara kita sa continuous charge distribution? So ang continuous charge distribution, it is just a conceptual model nga ginagamit naton to mathematically describe sang electric charge in a macroscopic object. But silingon, i-enlarge naton ang specific na object para padakuon siya naton or lantawon siya naton in a bigger and a wider nga perspective. Although, ang mga electric charge, gina-quantize na sila naton, or shall I say, all ng mga electric charges are multiples of a fundamental unit of charge. It is convenient to consider nga if we are talking about continuous charge distribution, makuha lang kita sang portion sang specific na object. For example, amo na ang aton nga isolve ang iyang electric field, and then we are going to perform some mathematical operation which is the integration. So if you could recall some concept of integration, so damo-damo ka, for example, if we are sa integration, ang ginahimo natin is we are finding the sums ng damo-damo diri nga slope sa specific na points. So same also apply, same nga principle ang kinahanglan natin nga gamiton if you will be solving for electric field due to continuous charge distribution. Again, maghambal kita nga continuous charge distribution, makuha lang kita sa gamay nga portion, amo na aton sumahon, dira kita ma-base sa aton nga solving for electric field, and then a perform lang natin ang summation through the process of integration. So, we can identify some continuous charge distribution. So both silingon, we have, for example, we have a specific line, isa ka line. And then, last time, gina-imagine natin nga maisa lang kita ka-charge and then sumahon natin ang electric field. This time, ang bilog ni nga line, puno siya sa specific na charges. And they are the same all throughout or uniform sila all throughout sa specific na line. Same also with, for example, you have a specific na sheet of charges. So, that means sa bisan din nga point sang isa ka sheet, same na may presence ang isang charge na kinahanglan natin i-consider. Same also with if you will be considering a specific nga volume, for example. So, pwede nga may ara kita specific nga volume ang kinahanglan i-solve. Anong himuon naton is makuha lang kita da sang portion and then amo na naton i-solve ang iyang electric field. So for the discussion, we will be having isang tatlo ka type of charge density. So basing on the concept of chemistry, kung balikan natin, when we talk about density, both silingon, we have a kung sa chemistry gid ang topic, that is mass over volume. But this time, since charge density ang ato na gina-consider, so that is charge per specific nga uh, consideration naton. So for example, we have linear charge density. Okay, so we have linear charge density. Okay, linear charge density, it is represented by lambda. So linear charge density is the charge density per unit length, and it is used to describe the charge of an object with a length far greater than uh, two other dimensions. So, ang linear charge density natin, it is represented by a formula which is equal to Q per unit length. So, that is charge per unit length or Q all over L. So, buot silingon, ano kada mo ang charge in a specific na length. That is your linear charge density. Next, another type of charge density nga kinahanglan natin i-consider is the surface charge density. Okay, so surface charge density, same with the concepts ng linear charge density. So we will be considering the number of charges na present in a specific na surface. So it is represented by gamma. So it is equal to your charges present in a specific surface. So that is your surface charge density. Also, we have volume charge density. Volume charge density. It is represented by rho, which is equal to the number of charges present in a specific volume. Okay, so take note that we are considering ang charges present in a specific nga consideration natin, whether it be linear, surface, or volume. I-consider natin siya as homogeneous or present siya all throughout, uniform siya all throughout. Nga kung magkuha ka tada isang portion niya, it will represent the whole totality ng specific na object. So, this time, paano naton sumahon ang electric field in this specific nga mga consideration. So for example, we have a specific na volume. So, okay, for example, you have this, take note lang, this is a specific na volume. So ang himuon naton, we have to consider a portion of this. We will have a specific nga, okay, so makuha kita isa ka specific na portion. And we will have same with the previous natin nga discussion. So we will have your point P here outside sa atong object or in space, and dira kita masuma sa atong electric field. So since this is gamay-gamay nga area or gamay-gamay nga part nga gin-enlarge lang naton or ginpadako lang naton, gin zoom lang naton. So this is ang bilog ning object. This is your charge. And since we will take only a small portion sa atong nga charge, i-label natin siya as dq. So, dq, what silingon the differential part lang or the gamay lang nga part sa atong specific nga charge. And this one will be, if we will be considering sang aton electric field, so kinahanglan natin mabalaan ang distance between this one pakadto sa aton nga specific point kung diin kita ma-measure sang electric field. And this will be labeled as R naton. So this is R naton. So the electric field due to the charge element dq, there is aton nga representation, will be solved gamit ang the same formula of Coulomb's law nga gin-discuss naton, wherein once sa previous natin nga discussion, we have E is equal to KQ all over R squared, and we have your direction UR. So, or pwede man nga R prime, depende sa aton nga pag-represent sa aton nga unit vector here. But this time, since we will be considering dq na, both silingon, we will be using dq here. So we will have dq. So both silingon differential charge ang aton nga i-consider, and at the same time, mga produce naton nga electric field will also be differential. So we will have dE naman dere. So dE, same also ang aton nga gamiton nga mga constant dere, we have k or the Coulomb constant, which is equal to, so ang k naton, so take note that ang ating ginagamit is 8.99 times 10 raised to the power of 9 Newton meter squared per column squared. Or if we have to use the formula nga gagamit kita sa vacuum permittivity or EO, free space nga permittivity of free space, so that will be equal to K naton is equal to 1 all over 4 pi EO. And if you perform sa mga calculation based on other nga mga materials or other nga mga books, probably may mga deviation kita or may lain kita sa ilang mga answer because they are using in the 8.99 but automatically ginagamit na lang nila as 9 times 10 raised to the power of 9. So, but it is a minimal lang man nga difference ang aton nga pwede ang aton nga makwadra. Okay, since we have a differential diri nga value, so in order to find sang atong electric field, kinahanglan natin mag-perform sang integration. So we have to integrate both sides now. So this will be equal to this one. So that means if we have to calculate for the electric field, aton nga formula will be equal to electric field is equal to the integral of dE, which is equal to the integral sa aton nga k dq all over r squared. Okay? This is not considering lang sa aton nga uh, ang aton nga unit vector dire. So because we will be having an approach which is a physics or the scientific approach kay para medyo masapos naton danay plus star ang discussion about sa aton nga discussion about electric field due to charge distribution. So let's start this discussion sa three types of electric field due to infinite nga mga number of charge by first understanding the electric field due to K line charge. So line charge ang ating una i-consider. So okay, so again, may I recall some different or nga type of charge density nga i-consider naton. First, we have okay, we have lambda or the lambda which is equal to aton nga charge in a specific nga length. Or if we will be considering na sang gamay-gamay na portion sa aton nga object, this will be equal to the differential nga charge all over differential man nga length, which is also probably differential of charge kung sa mga calculation na we will not be considering isang L but we will be considering X or Y depende kung di na present ang aton nga or kung horizontal or vertical ang aton nga line. So also we will have this one which is equal to your charge per unit area or your dq all over dA. And we will have your rho, which is equal to your charge in a specific volume or your differential charge in a differential volume. This one, take note that this is equals to column per meter. This one is column per meter squared and this is column per meter cube. Okay, so based sa aton nga unang calculation kagina, we were able to establish nga ang aton nga electric field will be equal to your integral of K dq all over r squared in a specific direction of your unit vector r. So, wherein ang aton nga dq will be can be represented by any of this depende sa aton nga sa kung anong ang gina-consider naton whether line charge, surface charge, or volume charge. So, pwede natin na-recall ang aton nga dq. Wherein ang aton nga dq will be equal to either we will have lambda dl or, or we have dq, which is equal to your, take note, this is sigma dA, and this is equal to dq rho dV. Okay, so okay, so now we are going to consider the electric field on a finite line of charge, Danay. So in order for us to have an understanding of full understanding sa electric field kung infinite na nga aton nga lines, ang aton nga line of charge, we have to consider first sang finite pa lang or may limits pa or bounded by specific limit pa ang aton nga specific charge. So we have to consider this one. So okay, so this one, ari ato ni consider ang horizontal nga side. For example, this is the line nga full of charges. So, amo ni ato nga line of charge. So, suppose ang aton nga uh, ang charge is uniformly distributed along the this one sa sining nga axis or the x-axis naton from a specific nga distance. So, let us consider ang bilog ng distance as L. So this means halin diri sa aton nga 0, this one is your negative 1 half L and this one is your positive 1 half L. And we will be considering the specific charge. Okay, so ang specific charge naton ari diri sa sining nga portion. Okay, so this will be, so ang una natin discussion, we will be considering DQ kay gamay-gamay lang siya nga portion. And then ang iyang nga distance diri will be, so let us consider, since ara siya sa x-axis, pwede natin gamiton x na lang. Okay, so and you have a specific nga linear nga charge density, since line ang atong gina-consider, will be considering lambda or your linear charge density. And if we solve, for example, your electric field, for example, in a line along sa x-axis, for example, we have your P here. So, kung for example, ara sa sining specific nga axis, same man with your line charge, dra ka ma-solve. So, pangitaon naton subong kung paano naton i-solve ang ating nga electric field. So, we have, okay, so this is your electric field, still the same ang Japanese formula. This is the integral of your K. dq na ito ni gamiton is your multiplied by your lambda. And we have, since we have a specific portion lang sang x-axis, so ang aton gamiton is dx all over your K. So take note, we have P here. So i-represent na lang ini nga point as your X, P. So halin sa aton nga origin, we have this point pakadto sa diri, represented diri, and we have this one. So ang aton nga R is this one halin sa aton nga dq pakadto sa aton nga P. So amo ni aton nga R. So let us represent this by R. So this is equal to, ang R naton is equal to xp minus x. So amo na aton nga gamiton diri, R naton is equal to xp. Okay, so this is xp minus x. And then we have to square this one. So this is equal to, this is constant, so we have k lambda multiplied by the integral of your dx all over xp minus x squared. Okay, para hindi kita ma-confuse, i-represent na lang xp by a para hindi kita ma-confuse. So we have this will be a, or a all over x na lang. So this is a minus x. We have a minus x squared. And we have So this is equal to, take note, we have to evaluate it halin sa diri sa piyak nga line para to sa piyak nga line. So from the unang endpoint, we have aton nga lower limit which is negative 1 half over L or negative 1 half L, and then we have the upper limit which is 1 half L. Okay, so paano natin i-perform ang aton nga integration? So we need to perform the integration by substitution. So let us let u natin will be equal to the more complex nga part which is equal to a minus x. Then natin nga du will be equal to negative dx. So take note that a here is a constant. So pwede natin i-substitute. So we will have k lambda. Okay, this is lambda, basi mo confuse. K lambda. We have your integral from k. You will have, so since negative ang ating nga dx, kinanglan natin og multiply sa sulod. So we have negative dx. We have also to divide, so pwede lang i-diretso ko lang di ang negative dx all over your a minus x squared. So this will be, kung may u substitution na kita, this will be equal to negative k lambda, your integral. Okay, this will be equal to your du all over u squared. And now we have simplified sa aton nga kabilugan nga equation. So dali kita pwede maka-perform sa aton nga integration. So your integral will be negative k lambda, and you will have u raised to negative 3 plus negative 2 plus 1. So that is equal to u raised to negative 1 all over negative 1. So this is equal to negative k lambda all over by 1 negative 1 all over u. If we are going to back substitute the values ng ato nga x, u natin is equal to a minus x. This will be equal to negative k lambda. So multiplied by negative, this will be positive na lang. So we have positive k lambda. So multiplied by your 1 all over a minus x. And this shall be evaluated from negative 1 half L up to positive 1 half L. Okay, so ato ng aton nga integration or definite integral. So we'll have k lambda sigwa. So we have to substitute sa aton nga lower to upper limit. So we will have 1 all over a minus 1 half L minus 1 all over a plus 1 half L. So this will be, so simplify natin ang ating tubilugan ng equation. So this will be k lambda multiplied by, so this will be equal to, okay, sa babaw, we will have, okay, so aton nga, okay, aton nga common denominator will be your a squared minus 1 half L squared. Then sa babaw, we will have a plus 1 half L minus your ari which is a minus 1 half L. Take note, pwede natin dali matanaw ang aton nga, okay, this one, pwede natin makancel ang aton nga A, and then ang aton nga L, 1 half L plus 1 half L will be L na lang. So we will have, this will be simplified into, you will have your K lambda at the numerator will be equal to L all over your A squared minus L all over 2 squared, which is equal to, so this is your K lambda L, multiply ko na lang or combine ko na lang sila, you have your, this will be equal to A squared minus L all over 2. Okay, so this is good na ni nga formula for your electric field. So, pwede na ni siya natin i-consider. Or pwede pa natin i-substitute ang value ng charge grid wherein natin nga lambda is equal to, since line charge siya, your Q or your lambda is equal to Q all over L. So, pwede kita dali makasubstitute pa. So, this will be equal to, so kung na-multiply kita Q all over L, so this will be equal to K lambda, so lambda multiplied by Q all over lambda L. Okay, so, ang aton nga lambda will be Q all over L multiplied by L all over your A squared minus L all over 2 squared. So this will be, makansel ang aton nga L. So ang aton nga simplified nga equation will be KQ all over A squared minus L all over 2 squared. So this is, pwede nga muna ni aton nga simplified nga equation. So any of this, so take note ang A is gingamit naton to represent sa aton nga distance ang aton nga P halin sa aton nga origin. That is your, kaya ang location sa imong P. So ginrepresent siya naton by A kaya para hindi kita ma-confuse. Okay, so we will have a simple example in order to illustrate sa aton nga discussion. So this will be, for example, na charge halin sa aton nga origin and 3 cm. So since we have a finite lang nga charge, so for example aton nga linear charge density or aton nga lambda is equal to 6 micro coulomb per meter. So we are going to calculate some P. Aton nga P will be ari diri. For example, we have this is equal to 10 cm halin sa aton nga origin. And then we are going to solve for the electric field nga mabatsyagan or ma-feel sa aton nga P diri or point P. So this will be simple, medyo complicated lang ang derivation, but your electric field will be equal to, so we have your K lambda L all over your A squared L all over 2 squared. So this is equal to K naton which is 8.99 times 10 raised to the power of 9. Lambda naton is equal to 6 micro. Then we have your L which is equal to 6 L. L naton is from halindari pakatudari. So this is equal to 3 cm plus 3 cm that is equal to 6 cm. Take note, dapat ato nga unit dari of length should be in meters. So divide ko lang siya by 100. So this is 6 all over 100 all over your A squared or your distance ng A halin sa aton origin. So that is equal to 10. 10 all over 100 dapat naka meter man. so squared, minus 3 all over 100 squared. So ang L over 2 natin is halin sa origin pakato sa isa ka endpoint. So that is 3 all over 100. So that will be equal to 2 if we calculate this one. This is equal to 8.99 E9 times 6e raised to negative 6 times 6 over 100 all over 10 over zero point 0.1 squared minus zero point 0.3 squared. 8.99 e to the 9 times 6 micro. This is 0.03. 8.99 times 10 raised to the power of 9. Okay, multiplied by, okay, we have 6 micro, 6 times 10 raised to the power of negative 6. And we have times 6 all over and all over 100 squared minus yung per 2 be all over 100 squared. Okay, we have 355,648. 355,648 Newton per column. So this is or 355 kilonewton per 356. Okay, this is one of the types of electric field or linear charge distribution. We will have another type of linear charge distribution and that will be discussed in the next discussion video. And also, I will be presenting more of the examples later on if tapos na nato ang tanan yung linear charge distribution. So this is it for now. So this may be lengthy or lawig na tama ang ating discussion. So this is it. Thank you. Stay safe. God bless.